Hey everybody, and welcome to this video on functions. So without further ado, let's get right to it. Alright, so before we go ahead and start discussing functions, we got to know what a function is. So the definition of a function is a rule or mapping or relationship between values in which each input has exactly one output. I often like to think of a function in terms of a function machine. So here's our function machine, and you give this function an input, and note, this input can be anything, a number, a word, anything. And the function machine has its rule, and the rule is going to operate on that input, and it's going to do something to it, and it's going to give out exactly one output, which again can be anything. Note, we're often going to be talking about numbers. Now, there are three main ways for us to represent the inputs and outputs to a function. The first involves making a table with the inputs and outputs on it. So here's a table, and all we're going to do is under the inputs, we're going to list our inputs, and horizontally from them, we're going to list their corresponding outputs. So for instance, this function might, for an input of -3, have an output of -15. And if you think about it in terms of our function machine, it's like when -3 goes into our function machine, the rule operates it, and our output is -15. For an input of 6, we have an output of 30. For an input of 120, we have an output of 600. And I'm going to go ahead and list a couple more input-output pairs. All right. Just goes to show we can have fractions, we can have decimals, we could have whatever number we want in this case. And perhaps you've already found out the rule here is that the output is equal to 5 times the input. Let's give this rule a name. Let's name this rule George. So the rule George says that to find the output, take the input and multiply it by 5. Now note, every single time we put in an input, we get exactly one output. It's never the case that for one input, we get 2 or more outputs. So George is a function in this case because every input has exactly one output. Now note, there are of course far more inputs and outputs that we can find, but for now, let's just stick to the ones we've got and try representing it in a couple different ways. So another way to represent these input and outputs to this function is with something called a mapping diagram. So the first thing we're going to want to do is we're going to want to make a blob and label that inputs, and a blob and label that outputs. In our blob labeled inputs, let's put all of our inputs, and for the blob labeled outputs, let's put all of our outputs. And now that we have all of our inputs and outputs in their respective blobs, all we do is we connect our inputs to their respective outputs with lines. One note, it's totally okay that these lines happen to crisscross. We just want to make sure it's very clear which inputs go with which outputs. We could have just as easily written the inputs and outputs so all the lines went straight across. But you don't have to. These two different mapping diagrams represent the exact same information. The third way we have to represent these functions is with something called ordered pairs. An ordered pair is just a set of parentheses with two entries in it separated by a comma. The first entry in that set of parentheses denotes the value of our input, and the second entry in that set of parentheses represents our output. So in this case, we could represent the function George by the following ordered pairs. And as you can see, in every individual ordered pair, the first number is the input and the second number is the output that goes with that input. So these are the three ways we have of representing our functions. Let's take a look at another function. Let's call it Philip. Now, I've already filled out this input-output table with some of the inputs and outputs for this function. Now, I hope that you haven't tried finding a formula for this function because, to be honest, there isn't one. I just picked random numbers. And this is a really important note that a function doesn't need to have a specific formula or equation for each of its input-output pairs. For instance, the rule for this function is that 5 is mapped to -3, and 2 is mapped to 17, and -1.4 is mapped to 5.6, etc., etc. Now, why don't you take a second to try to draw a mapping diagram for this function on your own? So why don't you pause the video now, try to draw a mapping diagram, and when you're done, play it, and we'll reconvene. All right, so here's our mapping diagram. Now, quick question. I noticed that a whole bunch of our inputs are all mapped to the output -3. So, is this indeed a function? Well, let's take a look at the definition again. Remember, a function is a relationship in which each input has exactly one output. Is that the case here? Yes, this relationship is a function. A function may have a single output that has multiple inputs. For instance, -3 has 3 different inputs that go to it, but that's fine. It wouldn't be okay for a single input to have multiple outputs. Okay, let's have you try to do the ordered pairs representation on your own. Once again, why don't you pause the video, try drawing out the ordered pairs for Philip, and then playing it, and we'll reconvene. All right, so here's our ordered pair representation. Couple of notes, always a really good idea to label your representation with the name of our function. Right now our functions have really nice names like Philip and George. Later on they're not going to have such nice names, but always a good idea to label them. And whenever you're doing an input-output table or a mapping diagram, definitely want to label the inputs and the outputs as well. Okay, let's look at another one. All right, so like I said before, while most of the time our inputs and outputs are going to be numbers, they do not have to be. So here's an example where neither our inputs nor our outputs are numbers. And let's name this rule something. We can name it whatever we want. Let's name it something random. Let's name it duck. So the name of this rule is duck. Now, perhaps you've already figured out the rule for duck. And in this case, the rule is the output is going to be the first vowel of the input. All right, once again, let's have you try to make the mapping diagram on your own. Why don't you pause the video, draw the mapping diagram, then play it, and we'll reconvene. All right, so there's our mapping diagram. Again, this is a function. Even though 3 different inputs all go to the output A, it's never the case that a single input has multiple outputs. A word can only have one vowel that comes first. It's impossible to have 2 vowels that both come first. So there's no way that one input is going to have multiple outputs. Once again, let's have you try to make the ordered pairs. Why don't you pause the video, make the ordered pairs, and then unpause the video, and we'll reconvene. All right, so there are our ordered pairs. For our next example, we're actually going to take the relationship duck and we're just going to reverse the inputs and the outputs. So our new rule in this case is going to be the output is any word whose first vowel is the input. So what does that mean? If we look at our table of values and mapping diagram and ordered pairs, all we're going to do is just reverse what our inputs are and what our outputs are. So I'm going to go ahead and do that with the table of values, the mapping diagram, and the ordered pairs. I urge you to pause the video. It'll take a little while, but please reverse the inputs and outputs to all 3 of those representations, and then we're going to discuss whether this new rule is actually a function. Okay, so here are the 3 representations for this new rule. So the big question, is this rule a function? Is it the case that every input has exactly one output? The answer to that question is no, and maybe it's the most obvious to see in our mapping diagram. It's clear here that the single input A has three outputs: baseball, cactus, airplane. In fact, if we think of all the words that have A as its first vowel, there are going to be tons and tons of outputs for that single input. So this rule is not a function. You can see it as well in our table of values that A is an input 3 times with 3 different outputs. And in our ordered pairs, there are 3 ordered pairs whose first entry are A, meaning that the input A has 3 different outputs. So in this case, not a function. Alright guys, that's it for this video. I hope you found it helpful, and I hope you enjoyed.